Hey, look. No. Okay, so here we go. I want to look at three quick examples of solving equations by completing the square. Okay, so let's start with this guy. Okay, so let's think about this. Let me kind of put this in a little bit of perspective in terms of what we're going to do, like what we're doing over the next few weeks in the class. So we're going to finish this section up real soon. Like we probably, obviously not this week, but, early next week we'll start testing over completing the square. And really what I want you to be able to do is this stuff. I mean, most of the test is going to be what we're doing today. I just want you to be able to solve by completing the square, okay? There's one other tiny little thing that we're going to add that's strongly related to this, but if you can do this stuff today, you're golden, okay? That's it. Then we're going to come back and we're going to look at one other method for solving quadratic equations, but eventually, not this test we're going to take early next week, but the next one after that is going to be about strategically solving quadratic equations. And so I like that test because it really forces you to think strategically about how to do some math. Yeah. So what you're going to have to do then is you're going to be given quadratic equations, and you want to pick the kinds of questions on that test will be really two kinds. Solve the equation, give me the solution, sure. But also there's going to be some questions that are going to ask you to do things like tell me what is the best way to solve this. And by best, I mean easiest, right? We want to pick the most efficient way to solve the equation. And that's consistent, sure. That's consistent with stuff we even do in calculus. In calculus, I've mentioned this many times already, I think, but most of what we do in calculus is not actually doing the math, it's figuring out the best way to do the math, so we can do it with the least amount of work and effort. So with this one, thinking about it in that way, all the questions on here are going to be ones that you're going to solve them by completing the square. But let's, so we're practicing that, but let's not lose sight of the big picture here. We would try other stuff first, right? I mean, if we look at this, the easiest way to solve any quadratic equation is by isolating x. Can I isolate x? No. Not the way it's written right there, can I? So that one we can check off the list. Let's go to step 2. Could we factor it? In order to know if we can factor it, technically we'd want to put it into standard form, right? So we'd set it equal to 0. Is that factorable?
No.
You'd have to find magic numbers that multiply to what?
2.
Negative 2, and add to, is that possible? No, it's not. So it doesn't factor. So then we move on to step 3, which is completing the square, okay? So when we complete the square, there's 3 broad brushstrokes to doing this. And then there's a little bit of work associated with each one, but there's really overall, at a big level, let's put phones away, please. At kind of a big picture level, there's just 3 things that we do every time to solve by completing the square. Step 1 is we got to put it into the form x squared plus bx equals some number, call it p. Okay? So we got to get the x squared plus bx by themselves on the left side of the equation. That's step 1, right? So let's do that. Step 1. One step. What do we do? Add 2. That's it. So we end up with x squared plus 7x equals 2, right? Okay. Step 2. Our second big step is complete the square. Okay, so now let's move down and let's do step 2. So step 2, we're going to start where we leave off with step 1. And if we complete the square here, we know that on the left side, we're going to get a perfect square, right? On the right side, we're going to get a number. I always want you to think about these 2 steps at the same time. Once we've set this up, so we know that we've got x squared plus bx on the left, we know for sure we're going to be able to add a certain number to those 2 terms to create a perfect square trinomial that's going to factor into a perfect square. So there are 3 blanks that we have to fill out here. that we have to fill in. All right, we've got some number added to x. I've got to add a number to both sides of my equation. And then I got to know what's there. Which one do I do first? Which color box do I do first? No. Whatever that is,
Same.
red or orange, whatever that is. That's the one we do first, right? That's the easiest one to do first. Because that's the one that comes, whatever B is, it's half of it, exactly. So there's step one. Fill in the blank. So it's good, don't want to use a decimal though.
4 1/2.
We don't want to use a mixed number either. It would be 3.5. 7 over 2, that's it. So dividing by 2 is the same as multiplying by 1/2, take your pick. But if I divide 7 by 2, I just get 7 halves. And I can't reduce that fraction. That's a simplified fraction. We want it as a fraction. Okay? So there's step one. Now which box do I fill?
Yellow.
Yellow.
First one.
Good. So now we go up here for step 2. We fill in the yellow boxes. What are those going to be?
14.
14 over 2
Not 14.
over 4.
No. How's that work? What's the relationship there?
Or wait, wouldn't it be?
This is half of B.
Be 49.
49 over 4. Yeah, how come? What do we do?
Because you square both
You
sides.
square it. There you go. Okay, so half of B squared is what you're going to add to both sides, right? And then finally, now we just need to know what does all this stuff add up to on the other side, right? So we got to get a common denominator. What's that going to be? 4, okay. So we'll multiply top and bottom by 4, and that's going to give us what? We're going to get 8/4 plus 49/4 is how many fourths?
57.
57/4. Okay, good. So we completed the square. Everybody get that? By completing the square, we filled in just the right amount of stuff on this side to create a square, a perfect square. Okay? So that was step 2. Now step 3 is going to be pretty simple. Step 3 is one you're most familiar with. Just isolate x. 2 simple steps. What are the 2 steps going to be? So let's rewrite this for step 3.
Square.
I've got x plus 7/2 squared equals 57/4. What are my 2 steps going to be?
Square.
Square root and then
Minus 7.
subtract 7/2, right? That's it. So step 3, isolate x. Again, you already told me what the ingredients are. We're going to square root both sides. So x plus 7/2 equals, if I square root both sides, what do I always have to add?
Plus or minus.
Plus or minus. And then I'm going to take the square root of this whole thing, right? But if I take the square root of the whole thing, if I take the square root of a fraction, how do I deal with that?
You square root the top and the bottom.
Square root the top and the bottom separately. There you go. So we're going to get square root of 57 over square root of 4. What's the square root of 4? 2. What about 57? Let's see, that's going to break up. 3 goes into that because they add up to 12, which is divisible by 3. 3 and what, 19? 19's prime, isn't it? So I don't get any couples out of that at all. So I can't take anything out. I leave it as the square root of 57. Okay, good. So then we end up with x equals plus or minus square root of 57 over 2. And then what's the last step?
Plus 7/2.
Plus
Or
or minus.
Okay, good. Where does it go?
In front of the.
Front of the plus or minus. So there's my 2 answers. Negative 7/2 plus radical 57 over 2, or negative 7/2 minus radical 57 over 2. Right? Okay. Good. So let's just move through a little more complex one, but it's the same stuff every time. Step 1, put it into that form. Okay. So what's that involved here? You got to get it into x squared plus bx equals some number.
So
Combine like terms. Good. We want to push everything to the side where A is going to be positive, right? So what's that going to give us? You guys can do that. If I subtract 4x squared to this side, how many am I left
2x
with?
squared.
If I subtract 4x, I get 10x, good. And if I add 14, so it's in standard form, okay? What do we always want to try to do here to make our lives easier? Greatest common factor, yeah. See if we can factor out some number and then divide it away, okay? What number divides into all those? 2, sure. So if you want to, you could just divide each side by 2. That's fine. That's fine just to do that. I'm gonna factor out the factor and then divide by 2. But you don't have to. You could just put a bar under both sides and divide by 2 and see what you get for each term. If I divide each term by 2, that's just as good. If I undistribute the 2, what am I left with?
X squared
Plus 5x plus 10.
Good. And it's equal to 0, so if I divide both sides by 2, I'm dividing that 2 away, aren't I? Right? So that's good. That's leaving me with a simpler equation, right? Now I reduced each of the coefficients, and the smaller the coefficients are, the easier my life's going to be doing this problem, right? So I've got x squared plus 5x plus 10 equals 0. What's the one last step I've got to put this into the right form?
Add minus 10.
Subtract 10. Good. I've got to get the x squared and the 5x by themselves on one side. So we subtract 10, and we get x squared plus 5x equals negative 10, and we did it. We got this into the form we wanted it into, right? Okay, now what's the next step?
You take half of 5.
Yeah, complete the square, right?
Yeah.
Okay. So we're going to get, we know this is going to break up into a perfect square. What's the number that goes there? What is it? 5 over 2. Half of B is 5 halves, right? So what's that mean? I have to add to both sides then.
25 fourths.
25 fourths, good. So we're going to add 25 fourths to both sides, right? And then we got to figure out what this adds up to, okay? So we'll make that over 1. So if I multiply this one by 4 over 4, what am I going to get? Everybody agree?
Yeah.
Plus 25 fourths is what? Negative 15 fourths. Good, so that's what we end up with there, right? So done, we completed the square. Okay, last step. Isolate by square rooting, or by solve by isolating x. Right? Square rooting and subtracting 5 halves, right? Okay, so if I square root now, if I square root both sides, okay, we know I've got to include my plus or minus, right? But when I square root, it cancels the squared. When I square root over here, I've got the square root of a negative number. That's not scary. It's no big deal. If I have a square root of a negative number, what do I have to do?
Take it out.
So what do I do?
You take it out and then you
Take what out?
the negative.
How do I do that? This is, well, no, I can think of
Multiply by
this,
the reciprocal.
and you don't have to show this word, but this is the same thing as saying the square root of 15 fourths times the square root of negative 1, right? So what's the square root of negative 1?
0.
No.
Or
I. It's I, right? So we don't even have to do that. We just know that when I see a negative under the radical, it's going to become an I outside of the radical, right? And then what's inside now is normal. Now it's just a regular square root of 15 fourths, right? So the square, I can break that up into the square root of the top over the square root of the bottom. Square root of 15 I can't reduce, can I?
So just square root 15 over
2.
Over 2, exactly. Square root of 4 becomes a 2. Okay? Everybody see that? So this stuff right here just all became that stuff right there. Okay, no big deal, right? We're good with that? On the other side, we've just got our x plus 5/2. So what's the last step then?
Subtract 5/2.
Yeah, subtract 5/2. So we end up with,
X minus 5/2.
yeah, x equals negative 5/2 plus or minus the square root of 15/2 times I. So I get two complex numbers. I get negative 5/2 plus the square root of 15/2I, and negative 5/2 minus the square root of 15/2I, right? Okay, one more, then we're done. Then you can just work. Okay, how about this one? Same kind of thing, right? You gotta collect all the like terms, add x squared, which leaves me with how many? 3x squared, okay, good. I add the 13, which combines with the 15 to give me, okay, is there a greatest common factor? Not, there isn't a greatest common factor for everything, is there? Right. So we move on, and now we've still got to get this in the form x squared plus bx equals p. So what are the two things I've got to do to get it into this form? Okay, one thing I got to do is I got to get the number on the other side, right? So one thing we'll do is we'll subtract 28. Okay, and that gives us 3x squared minus 18x equals negative 28. Okay, what's next? What's the other thing I got to do? Audrey, what else do I have to do? If I want to get this in the form just plain old x squared plus bx, what do I have to do to this side? Eventually I'm going to get there, but for now that x squared is not by itself, it's being multiplied by 3. Okay, so I got to divide each side by 3. Good. So we'll divide each side of the equation by 3. Now what's that going to give us? Okay, on the left side, that means I'm dividing each term by 3. So I get 3x squared over 3 minus 18x over 3 equals negative 28 over 3. That worked because the 3's cancel, so there's my x squared, right? So I get x squared, 18 over 3 reduces to?
Negative 6 over.
Okay,
Negative
good.
6x.
So minus 6x
And it
equals,
stays
and then that doesn't
negative.
reduce. I'm stuck with that, unfortunately, right? Okay, but we did it. There's step 1. We got it in the form x squared plus bx equals a number. What's b? Negative 6. Okay, so then if we know what b is, so what's going to go there? No. Okay, which is what? I get negative 6 over 2, which is negative 3, right? So x minus 3 is my perfect square. That's what's being squared. So then what goes up here? Negative 3 squared is 9. So I'll add 9 over 1 to both sides, right? And then now I just got to know what all that stuff adds up to over here on this side, and then I can just isolate x, right? So let's see, I got to multiply by 3 over 3, which gives me negative 28 thirds plus 27 thirds, which is what? Negative 1/3. Okay, so we completed the square. Last step is solve by isolating x. So let's put this guy, oops. Let's see, where's that go? So we complete the square. Oh, how am I going to do that? So I guess we'll put that like right there, because that's where we start to complete the square. And now we just solve by isolating x, right? So what are the two steps in order to get x by itself? Square root, good. Okay, so that gives us x minus 3 equals what? What do I have to, square root both sides, what do I need? Plus or minus, good. Plus or minus. Now the square root of 1/3, where does the negative go? Outside, so that's going to become an I, right? And then I've just got the square root of 1/3. Well, that's just the square root of 1 divided by the square root of 3. What's the square root of 1?
I.
No,
Or
square root of
this is
positive
just
1. This is 1, okay. So we get 1 on top and square root of 3 on the bottom, right? Okay, we can't leave it like that though. We can't have a stranded radical in the denominator. So what do we do if I have 1 over...
Times by square root of 3.
Good. We're going to multiply both the top and the bottom by whatever the stranded radical on the bottom is, right? Stranded square root.
Over 3.
Good. Square root of 3 times itself, meaning the square root of 3 squared, is 3, right? So we get 3 on the bottom, and on the top we get 1 times square root of 3. So I just get square root of 3 over 3, right?
Add 3.
And then I'm just going to add 3, exactly. So what does this become? When I simplify this, I get x minus 3 equals plus or minus square root of 3 over 3 is what that simplified to, times I. And then I'm just going to add 3 to both sides. So there's my answer. X equals 3 plus or minus square root of 3 over 3 times I. Okay? All right, so these are, I managed to get these. I want you just to see this. I'm going to let you work. If you look at, where are these things? Right there. So something like that guy. Okay, if you want to see how one of these work, just put in a wrong answer. And when you go through this is the hardest one I could give you. When you go through the solution, notice it's broken into those 3 steps. Get the equation in the right form. X squared plus bx equals a number, right? P, where P is a number. So it takes you through those steps. Once you've gotten it there, then you complete the square, right? So we know we're going to add a negative 3, b over 2. B is negative 6, so b over 2 is negative 3, right? So I'm going to add a negative 3 to the x. Negative 3 squared is 9, so I add that to both sides. And when I combine those numbers, I get negative 3 halves, right? Last step is just isolate x. So I square root both sides, right? Which gives me that. Does that make sense? When I simplify the radicals. And then all I do is add 3, and that gives me both my answers. Okay? So it gives you the solutions go through all 3 of those steps every time if you need a refresher. Okay? All right. Grab a Chromebook. How many people we got? 4, 7, 10, 11, 12, 13, 14, 15, 16. Would some of you mind? 1, 2, 3, 4. Well, grab these Chromebooks, and if we need to get a couple extras out of Mrs. Umbarger's room, I think we can. Just remember, if you grab one, so if you're grabbing one off of this stack right here, make sure you put them back up in this stack when you're done. Okay? All right, have at it.